morning, ladies and gentlemen. Today we are doing lesson 13. The objective says construct parallel line segments on a rectangular grid. So we're going to skip through several of these since we already did that, or I already did it. So I'm going to jump down to number 5. So it says, they had us cut out this little triangle right here, and it says, what are some things that you know about this triangle? Well, one of the things I know is that it has a right angle, and I can tell because I can bring my little post-it note over here and it fits in there perfectly. So we have one right angle. So that means the other two angles are not right angles, those are acute angles. So there is one right angle and two acute angles. Another thing I can notice is that there are 1 and 2 units tall and 1, 2, 3, 4, 5 units long. And the other side is 5 units. So the next one says, place your triangle on your paper so that the horizontal side is 5 units and the 90-degree angles is to the right. So we have it right here. And it says label the right angle and name its vertex R. We already did that. Check, check. Okay, so it says name the vertex. So yep, we did that. That one's already done. We already labeled it S and T on our acute angles. And it says place your straight edge horizontally, so horizontal like the horizon, across your paper. Then place the base of the triangle along the straight edge. So this right here is our base. I'm going to put it right here. And it says trace a line across ST. So the line that says ST. Okay, so then it says slide triangle RST, so this right here is RST, so it's our triangle, to the right about 1 inch. So right there. Along your straight edge without moving the straight edge. Trace a second line across ST. Then it says, remove the triangle and the straight edge from our paper. What do you notice about the 2 line segments you've drawn? Mrs. Delahunt, what do you notice?
Well, if I were to put my straight edge along them and trace them even longer, I notice that they will never ever intersect, and lines that don't intersect are parallel.
Awesome. So they are parallel. Okay. So the next one says, try all this again. This time arrange your straight edge so that it's oriented vertically on our paper. But we're going to skip that part. I'm going to show you an example of it. So if we had done it, they're just saying that we would do it this way, draw a line, and then we'd slide it over. Same thing, our lines are still going to be parallel. Problem number 2 says, put your finger on line segment AB. So they're talking about this one right here. It says, using the grid lines, visualize a right triangle that has AB as its longer side. So right here, this would be the longest side, and they want a right angle. So I would bring my finger down here, bring it over here. So here would be my little triangle. And it says, explain what you see. Well, I would see that our triangle is 2 units tall, and 1, 2, 3 units long. And I would say that this right here would be a right angle, so we have 1 right angle, and these 2 would be 2 acute angles. so number 3, it says the triangle has a height of 2 units. We already showed that. And a base of 3 units. So right here would be our 3. It says mark a right angle with the right angle symbol. Shade the triangle on your paper. So right here. And there's our right angle. Now look at segment CD. Shade a right triangle that has CD as its longer side. So look here, this needs to be my longer side. So I would draw a line here, and then I would draw a line down here. So right there would be my right triangle, or my right angle. So, number 5, what do you notice about the 2 triangles that were used to construct each segment? So, well, I would take a look at them, and I would say here they both are 2 units tall, and they both have 3 units on their base, and they both have right angles. So the only thing that's different would be that it looks like this triangle was just scooched over here. So we can say they're exactly the same. Just CD was moved over. This is the same as when we slid our triangles along the straight edge. Now the triangle is sliding along the grid lines. Can we say then that segment AB is parallel to CD? Why or why not? What do you think, Mrs. Delahunt?
Well, I think that yes, they are parallel.
Okay. Yes, they... Okay, so then, alright, for number 7, it says to repeat the process with EF and GH they have right here. I'm just going to show you. So this one, it's a little different than this one. Instead of just, this one moved over, but then it also moved down one. But they are still parallel. They still intersect these little guys at the same angle, and they both still have a right angle on the same straight line like right here. So they are still parallel lines. Then we're going to go to problem number 2. It says look at the segments IJ right here and KL right here. Shade the right triangles that have these segments as one of their longer sides. So again, I'm going to draw my line down. Right there's my right angle. And for KL, right there is my right angle. Done. Are these segments parallel? What do you think, Mrs. Delahunt?
Well, I think if I were to take my straight edge and lay it on KL, I think that I could see that KL will eventually run into line IJ. So no, I do not think they are parallel.
Excellent. Good idea to laying the straight edge down, because yes, that one will eventually intersect. Alright, it says extend the segments, and yeah, we already explained what is going to happen. So if I extend that, one, yes, Mrs. Delahunt is right. They do eventually intersect. Number 12, imagine that we slid the longer segment over 1 unit to the right. Would these segments line up perfectly? Why or why not? What do you think, Mrs. Delahunt?
I don't think so. I don't think they would, because if you look, KL is actually 1 unit shorter, so their angles are not the same on that bottom corner.
Right, yeah, and if we even showed it, if we slid it over, still not going to be the same. Alright. Because they have different angles. Number 13, it says look at segments MN and OP. So it's asked, are they parallel segments? Explain. Well, if we look at them, it would help if we could visualize a triangle. It looks like they're parallel, And it says right here, can you see a triangle for MN that has, well, we can visualize it, that has the height of 2 units and a base of 2 units. So right here, we're going to shade it in. So right there, we have a right angle. Then it says, it looks like OP is the side of a triangle with a height and base of 4 units. So we count 1, 2, 3, 4. And then a base of 4 units, 1, 2, 3, 4. Right here, another right angle. So yes, they are parallel. Okay, so then we have, it says, look inside the larger triangle. Do you see 2 triangles like the one related to MN? So if we look, we can compare. Instead of drawing a bigger triangle, we could draw 2 little ones. So right here, this one has a base of 2. So we could draw, there's a base of 2, and there's a height of 2, still right angles. And if we do another one, we could do one here. There's a height of 2, there's a height of 2, and a little right angle right there. Alright, so we have 2 triangles exactly like MN, and we could do other ones. We could do one there, but we'll just do those 2. So now it says, what do you think now? Are the segments parallel? What do you think, Miss Dilliant?
Yes, I think they are.
Yes. Yep, but OP is a little bit longer, but they are still parallel. And do not forget to do your exit ticket for today.